Chapter 19, Testing Hypothesis about Proportions Example, Test Statistic. To test a new campaign, an organization sent donation request letters to 100,000 random mailing addresses in the U.S. and received 4,781 donations. It had a contribution rate of 5% in the past. They are concerned that this campaign will lower returns. So we have a sample size here of 100,000. Our p hat is represented by the 4,781 donations that were received out of the 100,000 mailing addresses. So that gives us a p hat of 0.048. Our p naught is 5%, because that's the contribution rate that they've had in the past, and 1 minus p naught is 0.95. So the first thing that we want to do is write the appropriate hypothesis statements. So our null hypothesis, p equals 0.05, because if you recall, the null hypothesis assumes that nothing has changed. So in the past, the contribution rate had been 5%, so therefore a null hypothesis is based off of that 5%, p equals 0.05. Our alternative hypothesis, or HA, is p less than 0.05. Okay, let's stop there for a minute. How do we know to use a lower tail test? Well, in the question, it says they are concerned that this campaign will lower returns. So what we want to test is, does this campaign lower returns? And if the contribution rate had been 5% in the past, we're testing, does this new campaign lower that rate? So we're going to use a less than, p less than 0.05. So the second part, what type of test is being performed? We're performing a one proportion z-test. Let's look at our assumptions and conditions. Our independence assumption. We'll first look at the randomization condition. Okay, so the problem states that the mailing addresses were selected randomly. It tells us that right in the problem. The 10% condition. Well, 100,000 is less than 10% of all U.S. mailing addresses. So that condition is satisfied. Those two conditions are satisfied, therefore our independence assumption is satisfied. So let's continue with our assumptions and conditions. We have to look at our sample size assumption, and we have to check our success-failure condition. So our n is the 100,000. Our p naught is 0.05. That gives us 5,000. Our q naught is 0.95, so we multiply that by 100,000, and that gives us 95,000. Both of those values are greater than or equal to 10. So therefore, our sample size assumption has been satisfied. So all assumptions and conditions are satisfied. The next step, let's calculate our test statistic. Well, the standard deviation of our p hat is the q naught times p naught divided by n, and then we take the square root of that value. That gives us the square root of 0.05 times 0.95 divided by 100,000. That gives us a standard deviation of our p hat, 0.0007. So now we have all the components that we need to put into our equation to solve for z. So we use our p hat, which is 0.048, minus our p naught of 0.05, divided by our standard deviation of p hat, 0.0007. That gives us a z-score of negative 2.86. So the next step is we want to test the hypothesis at a significance level of alpha equals 0.05. Since we've been given our alpha is 0.05, we have to find the rejection region associated to that. So what we want to know is, what is the z-score associated to an alpha of 0.05? So since this is a lower tail test, remember our alternative hypothesis was p is less than, that makes it a lower tail test. So we want to know what z-value cuts off the lower 5% of the normal curve. So what you want to do is go to your z-table, and you want to go into the body of your table to look at your areas, and what we're looking for is 0.05. Well, there is not a specific 0.05 in there, but what there is a 0.0495 and a 0.0505. Okay, well, 0.05 is in the middle of those two numbers. So what that means is our z-value is going to be in the middle of that as well. So the 0.0495 is associated with a z-score of negative 1.65, and the 0.0505 is associated with a z-score of negative 0.64. So the z-score that's associated with 0.05 in the area is going to be in between those two. Well, the number that is directly in the middle of negative 1.65 and negative 1.64 is negative 1.645. So that's going to be our cutoff area. Now, we've calculated that our test statistic is negative 2.86. So if you look at my sketch over here on the left, I have my shaded area is the 5%, that's my rejection region. And my cutoff for that rejection region is negative 1.645. Well, my test statistic is less than negative 1.645, it's negative 2.86. Therefore, my test statistic is in my rejection region. So that's going to lead me to reject HO, or reject the null hypothesis. So in my conclusion, recall I have to state my conclusion in the context of the problem. So what I'm going to say is reject HO. There is enough evidence to support that the donation rate dropped below 5% at a significance level of alpha equals 0.05.